let's look at Cobb-Douglas. Preferences, and so remember these are preferences where this utility function u of x1, x2 has this form, x1 to the c, x2 to the d. And remember we could take a monotonic transformation and we could say the log of it. Maybe I'll do that in the line before. It's below the log of u, x1, x2. So this monotonic transformation is like c ln x1 plus d ln x2. So essentially what we're trying to do here is we're trying to maximize this subject to our budget constraint. And we get to pick x1 and x2. So this is our problem, right? And we can kind of think of 3 ways to solve this, or we've looked at 3 ways to solve this. We had the MRS condition that we talked about before, so just using that straight condition. We talked about unconstrained, reframing as an unconstrained max problem, and then we talked about using a Lagrangian. So these are the 3 methods that we're going to show are the same way. We're going to get the same answer as we do. We're going to get the same answer all 3 ways. That's all I'm trying to say. And so this is when we know the partial derivative, the ratio of the partial derivatives equals the price ratio, and then we also have that, then we have the budget constraint as well. So we have 2 equations and 2 unknowns. So the MRS condition, the partial with respect to, the ratio of the partial with respect to x2 and x1 of that utility function is this. C times x1 over d, C times x2 over d over d times x1. And that equals the price ratio, P1 over P2. And we solved for this, we showed this last chapter last week when we used Cobb-Douglas. We showed that, this was the marginal rate of substitution for these Cobb-Douglas, or it's a negative, the marginal rate of substitution for this Cobb-Douglas. And we also have this budget constraint, P1 x1 plus P2 x2 equals m. So here, 2 equations, 2 unknowns. So we can express, we can use, let's call this, 1 and 2. We can rearrange 2, maybe we'll call it 2 prime. Well, let's not call it that yet. We can rearrange 2 and solve in terms of x2 in terms of x1. No, we've done this a couple times already. M over P2 minus P1 over P2 times x1. We've done that a few times, rearranging this. And we're going to plug this in to this equation 1. So we just kind of reformulated this second equation like we've done a couple times, and we're plugging it back in to 1, and we're going to plug it in for that. Oh, sorry, we're going to plug it in for x2, the numerator. Better. All right, so that's all I'm going to do. C times m over P2 minus P1 over P2 times x1. So this, in brackets, is I'm just replacing x2 with what we wrote out here, over dx1 equals P1 over P2. Then I'm going to cross multiply. So I'm going to cross multiply, so I have P2 times C, m over P2 minus P1 over P2 times x1. So this times here, this times this, equals P1D x1. We can cancel a few things out here. The P2s are going to cancel out. I'm going to move this P1 over, and I'm going to isolate x1. let's rearrange. Let's see if we have enough room on these boards here. Hopefully this is going to fit in. So I'm just going to rearrange this. And so C times M equals C plus D times P1 X1. So I'm just C times M, C times P1, but it's minus C times P1. I'm just moving that over. And then I'm isolating for X1, right? So I'm just multiplying this through to leave the CM on this side. I'm multiplying C times minus P1 times over X1. I'm just moving it over there. Sorry, P1 times X1. This X is in the numerator. That's not clear. Maybe that's better. All right. We can rearrange. We're just solving for X1 here. So X1 equals C over C plus D times M over P1. So that's our demand function for good 1. Now we can do, for good 2, we could plug this into the budget constraint and solve for good 2. But we're going to get D over C plus D times M over P2. So those are our two demand functions for the Cobb-Douglas preferences using this MRS condition. So we're just using this MRS condition, which is the ratio of margin utilities equals the price ratio. We also know we have to satisfy this constraint. We rearrange this constraint so it's good 2 in terms of good 1. Plugged it in up here, and then we just solve for X1. We can plug that X1 back into our budget constraint, and we'd solve for X2, and this is what we'd get after just a little bit of algebra.